Speed of a wave. A wave is defined to be a disturbance that propagates. And propagates means there is motion. And whenever we talk about motion, this means that there is speed. The fact is that the speed of a given wave remains the same, constant in the same medium. That's why we can use the following formula to calculate the speed of a wave in a certain medium. V equal distance over delta t. This is a rule to be memorized, where V is the speed, distance is the total distance d covered by the wave, and delta t is the time needed or duration by the wave to cover the distance d. So here we have to write delta t, not t, in order to show that this is duration, not instant. Application. Given a mechanical wave propagates at a speed of 200 meters per second in a certain medium, calculate the distance covered by this wave during 10 seconds. Using the formula V equal distance over delta t, we can do cross multiplication. Distance equal V times delta t, which is equal to 200 meters per second times 10 seconds. Now seconds in the numerator and seconds in the denominator cancel, so we are left with meter as a unit of distance, and the value is 2000 meters. Speed of a wave. So far we know one unit for, or one formula, sorry, for calculating the speed of a wave. Now we need to prove this other formula, V equal lambda over period. We know that for one cycle of a wave, the distance covered by the wave, the total distance covered by the wave, is equivalent to lambda. And the time needed to cover the distance lambda is the period. So if we substitute distance by lambda and duration by period, we get the following formula. The speed of a wave remains constant in the same medium. You have to keep this in mind. And the speed of a wave changes as a certain wave propagates from one medium to another. Now the relation between speed, frequency, wavelength. So according to the previously proven formula, F equal n over delta t, and period is delta t over n. So you can see that the numerator of one is the denominator of the other, and the denominator of F is the numerator of the period. So that's why we consider that F and the period are the reciprocals of each other. So we can find or conclude another formula here, which is F equal 1 over period. This is also a rule to be memorized. The SI unit of a frequency is hertz, and the SI unit of period is seconds. Now we already have that V equal lambda over period. This can be written as V equal lambda times 1 over period. Now instead of 1 over the period, we can write by substitution V equal lambda times F. So this is another formula, another rule to be memorized and used. You use the appropriate formula according to the given information. So there are three formulas to calculate the speed of a wave. V equal total distance over duration, V equal lambda over period, and V equal lambda times F. It all depends on the given information. Application. Given a mechanical wave of wavelength lambda equals 5 meter, propagates at a speed of 10 meters per second in certain medium. Calculate the period of this wave, then deduce its frequency. The period is lambda over V. So using the formula V equal lambda over period, we can consider that V is V over 1 is equal to lambda over T. Now period over 1 is period equals to lambda over V. Doing the calculation, I think it's easy for your level. So you can say that the period is lambda over V. Now doing the substitutions, 5 meter over 10 meter per second, meter and meter cancels. So we are left with the unit seconds, unit of time. So 5 over 10 is 0.5 seconds. Then deduce its frequency. Using the formula F equal 1 over period, and having already the period in SI unit, we can simply substitute F equal 1 over T. 1 over 0.5 seconds equal to hertz. The SI unit of frequency is hertz. It's equivalent to cycles per second, but we do not use cycles per second, we use hertz, capital H, small z. A wave is identified by its frequency. As the wave propagates from one medium to another, its frequency remains the same, but its wavelength changes due to the change of its speed. So as you can see here, I try to do an analogy between the identity card of a person and the identity card of a wave. Just as we people carry our identity card everywhere we go and being identified by our name, in which this name doesn't change as we go from one place to another. Similarly for the wave. As a wave propagates from one medium to another, its frequency remains the same. Its frequency is just like the name for us. So now we have that V equal lambda times F already proven. We can say that F equal V over lambda. Divide both sides by lambda. We get that F equal V over lambda. Now for the same wave, we have that F equal V over lambda. So for the same wave, the frequency remains constant. This means that this ratio of V over lambda is constant. And mathematically, we know that if the ratio of two parameters is constant, this means that they are directly proportional. So here, it's not inversely proportional, they are directly proportional. So as V, so having V and lambda, the ratio of V and lambda to be constant for the same wave in the same medium. So as the speed increases, the wavelength increases too, so they are directly proportional. Now, if the same wave propagates from one medium to another, it keeps the same frequency, but changes its speed. The change in the speed leads to a change in the wavelength of this wave. For the same frequency, the wavelength and the speed are directly proportional. So, as the wave propagates from one medium to another, the speed changes. If the speed increases, then the wavelength increases. If the speed decreases, the wavelength decreases. However, if we consider two waves of the same nature propagating in the same medium, they propagate at the same speed but have different frequencies. So for the same speed, the frequency and the wavelength are inversely proportional. So because V equal lambda times F, we have that the product now of two parameters is constant, not the ratio, the product is constant. So V and lambda, lambda and F are inversely proportional. So having V equal lambda times F, where V is the same for these two waves in the same medium. So as the frequency of one of them increases, its lambda decreases, as you can see in the figure. So here wave 2 has more frequency than wave 1 because more cycles are being performed at a certain or within a certain interval of time. But as you can see that the crests are coming closer to each other, this means that the wavelength is decreasing. So F increases, lambda decreases.